Terraform Stacks with YuZhao Zhang. Hey everybody, welcome back to the show. Welcome to vBrownBag. We are getting close to the end of the year. Happy holidays to those who celebrate. Also, happy post reInvent, Shala. It was so good to see you there. We did get the best selfie ever. Everybody that knows us knows that you are now the tallest amongst the two of us. I was disheartened to learn that you tower over me. Welcome back.
Wouldn't it be crazy though? Like if I was like 6'8" and wore heels. That's something I would do.
Aaron Hunter would have been exhilarated and terrified simultaneously. I would have, dude, if you were taller than me, legit, I would have brought you around to like Ross and Calvin and all those other tallies and just been like, yo, this is my co-host. Take that. YuZhao, welcome to the show. It's a pleasure to have you on. I loved chatting with you at HashiCorp. So full disclosure for everybody watching, YuZhao and I both work at HashiCorp. So this is a third-party episode. This isn't some kind of like commercial for Terraform or anything like that. We're going to get into the nitty-gritty. We're going to ask the hard questions today.
So he says.
Look, I mean, the reason I work there is because it's a cool product, but I'm not going to sit here and like say it's like perfect. It's certainly not. So we are here to talk about Stacks. It is finally GA. The first time I saw it was announced as a beta. 2 years ago? I think it was 2 years ago. And
2 years ago, I believe.
Yeah, 2 years ago at HashiConf 2020, my first HashiConf, it was announced as a beta, and then it languished as a beta for a long time. It is finally GA as of this year. And so we're going to kind of get into it because I have a lot of questions. I know about it. I've spent some time with it, but I've kind of kept myself in the dark because I want to be able to ask newbie questions. Shala, have you played with it at all?
No.
Perfect. All right. Well, then we're both exactly in the same boat.
But I do want to hear about it because I did get to hear a good amount about it when I got to do the Ambassador Day at HashiCorp, which was nice. So yeah, I want to get into it.
Yeah, definitely. Cool. So YuZhao, you're based in California, and you've been with HashiCorp longer than I have, haven't you?
That's a good question because I started in December 2020, then I left in 2023, then I came back, last year in October. So altogether, it has been over 3.5 years.
Okay. So you do have more tenure than me. You have longer tenure at HashiCorp than I do. So I will defer to your expertise.
Sounds good. I'll try my best.
Cool. Well, I mean, this is not a gotcha show. There's no like gotcha questions or anything like that. We're not going to be like, doing anything sneaky by any stretch of the imagination. This is just going to be us having fun, learning about Terraform Stacks and getting to know each other. So what got you to HashiCorp? What made you come and work on Terraform? What's your background?
That's a good question. I started my career as a software engineer. I was in China, then I moved to Canada, Toronto. Then I work as software engineer over there.
Oh, I love Toronto.
But I moved to San Francisco Bay Area because it's a better place for my career. At the time, the cloud started getting lots of attention from people. So, I started learning about cloud. Then once I got the opportunity to join HashiCorp, I was so excited because I want to work more on the cloud. So that's why I joined HashiCorp actually. Also, I got certified as AWS Solution Architect Associate, in the first 3 months after I joined HashiCorp.
Oh, nice. Very cool. So you think this cloud thing is going to be around? You don't think it's going to be a passing fad? I think it's a fad. I think we're going to get back to PCs and data. Never mind. I'll shut up now.
Maybe I think that maybe the trend is going to be decentralized systems. You don't know, right? Could be.
things started with the mainframes, then they decentralized, and then they re-centralized, then they decentralized again. And now it feels like with AI, potentially well, I don't know. I've stopped making predictions on where technological trends are going to be going once things virtualized the third time. So awesome. Cool. Well, I'm actually kind of eager to get into this. So why don't we go ahead and cut over to it and get you going? Are you okay with that, or was there anything else that you wanted to talk about first?
No, I'm good. Let's kick
Okay,
off.
let's do it then.
So first, I'm YuZhao. I'm the solution architect at HashiCorp. I have to start by saying it's exciting to be here because we announced at HashiCorp that Terraform Stack is now generally available as Chris just mentioned earlier. We built Stack to solve the biggest pain point. We hear from platform engineers, how to stop being a pipeline chaperone and start delivering infrastructure at true scale. So today I'm going to show you how Stacks combine with the power of AWS and allows your team to simplify provisioning, accelerate delivery, and reduce risk. I already introduced myself a little bit, but I want to talk about a little fun fact of me first. I'm ballroom dancer. I used to compete.
Nice.
I'm a scuba diver. I enjoy scuba diving. I was a couple of weeks ago. I was in Komodo Island, Indonesia. So I saw.
Oh my gosh,
I did scuba diving over there. Also, I saw the Komodo dragons at the same time.
So
did they get in the water too, or
they don't? They can swim, but they don't like water that much.
How big do they get? Because I know that they're we're totally sidelining here.
It could be 3 meters.
Bigger than me.
Wait, 3 meters?
Yeah, it could be 3 meters.
They get huge.
So for perspective, Shala, I am 2 meters tall. So that's 1/3 more taller than that's giant.
I told you bigger than me. Like
it's 1.5 Shalas tall. What? That's amazing.
I'm just saying.
Oh my gosh. Sorry.
Yeah, okay. A Terraform is great, and some of our users even describe it as magic. But once our customers and users grow their Terraform configurations, they run into challenges in the core provisioning workflow that Terraform does not address. And the magic starts to wear off a little bit, to optimize configurations for speed, security, and maintainability. So the best practices is to adopt a small, modular, and composable approach. But this creates 2 core challenges. The first one is to do with the dependencies management. So that's something Terraform does really well within a single workspaces. Terraform builds a graph of dependencies and plans and applies everything in the configuration in the right order. However, the challenges developers face is when dependencies don't all live in one workspace. So there are a number of reasons to keep things modular, such as different provisioning lifecycle separate, reducing long run times, or separating code across team boundaries. So this is where we find users making trade-offs between either putting as much of their infrastructure into a single workspaces to take advantage of Terraform native dependencies management, or splitting infrastructure across multiple workspaces and managing those dependencies manually or with some custom tooling. That's why I'm not sure if you know, there's a feature called run triggers. So we use those, to link workspaces to make them to work together. Mm-hmm. So the second challenge is repetition. So as organizations scale, they have to duplicate workloads across dive, staging, and product environments. So even multiple cloud regions. So these results in dozens or even hundreds of workspaces that all have to be managed independently. Any questions here? No?
No, this makes sense.
Cool. So that's exactly why Stacks has built to solve. So Stacks replace the traditional root modules in your Terraform configuration with a new powerful configuration layer that will make it possible to describe not only what you want to provision, but how and where you want to provision it. So we want to introduce 2 powerful concepts. First is components. So components are just for standard Terraform modules, but by defining them inside the stack, your organization modules that share a lifecycle together, this will allow you to take full advantage of Terraform's native dependency management, which will solve your cross workspace dependencies problem without needing any custom tooling. The second is the deployment. This is how you achieve the true repetition and define how and where instead of manually creating a number of resources. So every time you run a new environment, you simply add a new deployment block, your configuration, define the inputs, and the stack spins up the required isolated infrastructure for you. So the result of these are optimized coordination, provisioning, and management. So this is how brings up two huge benefits. Number one is that Stacks eliminates the need to manually manage cross-configuration dependencies. So we organize all related modules using components. And for systems that must be separate, we can also connect multiple stacks together where changes in one automatic initiate operations in another one. So no more batch scripts required. Like what I mentioned about run triggers before, you don't need that anymore. So the second benefit is that you can quickly create and modify consistent infrastructure setups with different inputs, all through a single action. So you leverage deployments to actually repeat your infrastructure and use orchestration rules to automate the rollout of changes across all instances. So let's talk about some of the major enhancements we have made. So I will start off with something we have done to simplify orchestration, which is what we call deployment groups. In this initial release, we have introduced the structure of deployment groups. So the feature allows you to group related deployments together. So you may have multiple deployments that you want to control at the same time, and you may need to modify certain settings across all of them. You can wrap them all into one deployment group and apply those common settings. However, this means you can have 20 deployments per stack. So in this GA release, you can assign one deployment per deployment group, and you'll also be able to apply an auto-approved checks. For example, automatically applying a plan if it doesn't contain any destroy operations. So I will show you a little bit more in the code. Also, I will talk about the future releases we have in mind for deployment groups later. The next one is link stacks. This problem we want to resolve is very straightforward because not all infrastructures can live inside a single stack. So you have core resources, you have landing zones, and shared networking that must remain separate. So when a foundational resource changes, that change needs to automatically cascade to all dependent downstream infrastructure. So our answer to that is link stacks. And it has been available for use since earlier this year. Actually, the beta was released in February this year. So this feature works just like run triggers for workspaces, but it builds natively into stacks and it defined as code. So it means it gave you three main features. Number one, it allows you to explicitly link one stack to another. Number two is output from the foundational stack can be used as inputs to the dependent stack. And lastly, and most crucially, so any change to the foundational stack will automatically trigger the plans in all affected downstream stacks. So the result of this is a seamless experience. So you can get a clear web-based view of all your cross-stack dependencies, and you can update foundational services like networking, knowing that entire system will respond automatically and correctly. So here's a quick view of the link stacks will look like. So you will publish your output, then call it published output. So some IDs from the simple and the complex deployments. And this is an upstream stack here. The next one is self-hosted agent support. To serve as a platform for enterprise infrastructure, we must support your most critical security and operational requirements. This release removes as a major adoption blocker, which is network isolation. Some infrastructure must be managed with tightly controlled environments where security compliance or regulatory constraints are non-negotiable. So to fully support these use cases, stacks include full self-hosted agent support. This feature ensures that all Terraform planned apply operations for your sensitive stacks run inside your private network, even in the air-gapped environments or behind firewalls. To maintain control over how and where these sensitive changes will be applied. So crucially, you can also scope agent pools to specific stacks the way you would do with workspaces. This means you can align execution settings that your production stacks run only on agents dedicated to your most secure infrastructure. This will provide your greater flexibility for hybrid and on-premise environments, satisfying your strict audit requirements. But as a screenshot here, how it will look like in the UI today, you can pick particular stack, you can pick a particular workspaces, you can apply to a project or multiple projects. Let's moving on to version control support. We recognize that for stacks to be the engine behind our enterprise scale deployments, it must meet your most stringent security requirements. Our challenge was that the initial workflow that we launched has a public beta-like support for some key enterprise providers like Azure DevOps or Bitbucket. So it also lacked IP allow list support. We have solved this by delivering full enterprise gate VCS support. This allows your team to securely source configurations from all of the major providers. You see in the screenshot here, you're able to use GitHub, GitLab, Bitbucket, Azure DevOps. So everything under the umbrella. Now this allows your team to work with whichever partner you prefer. More importantly, we also implemented IP allow list policies on the VCS connection. So this will ensure not only trusted secure network sources can access your VCS system. This result is improved security and compliance for infrastructure deployment and seamless integration with your existing enterprise workflow. Next one, I really like it, is CLI support. So we have been able to tackle developer productivities by fully unifying this experience. You know, the standalone Terraform stack CLI, if any of you have tried out public beta, so it's now been merged directly into the main Terraform CLI. It simplifies your toolchain immediately. For devs, this means greater velocity. So you can now create, manage, and iterate on stacks directly from the command line, and you can run quick experiments. You can validate your setup, you can create configurations without needing a connected VCS. So this removes that friction barrier for authoring new stacks. For platform team, the CLI grants you granular control over your deployments. So you can now trigger, plan, and apply operations for some of our deployments in a stack directly from your CI/CD pipeline. So this will ensure that even while using VCS as your source of truth, you have full automated control over your state deployment workflow. On the right-hand side, you see there's a bunch of commands, the list here, that you're able to try out. So you will notice it covers almost everything you need to do directly from the CLI. Because I tried stacks when it was in the public beta, so the only thing I was able to initiate stack is through the UI. So these features really means a lot, you know, after GA. Mm-hmm. Finally, you know, I'm not sure if the audience will care. It's about the billing, because in HashiCorp Enterprise, we charge customer RAM is resource under management. So the stacks will same as the workspace. It's going to be under the resource under management. Okay. Do you have any questions here? Because I would like to share some use cases.
I have several dozen questions, but
Okay.
I want to make sure that okay. So let me get a couple of questions out of the way. So I'm assuming that in the demo you're going to get into components and deployments and some of the conditionals and all of those things. From the okay, so you had run pricing up there, so I feel like this is a fair game question right now. HCP Terraform has a 500 free. They have a free tier where you can have up to 500 resources under management underneath the free tier. Does Stacks implementations count as part of the 500 free tier? Can you use Stacks in the free tier of HCP?
I don't think so. I don't in the free tier because I'm not good at the pricing part because my job is solution architect. Normally I just provide solutions, but I'll get back to you for this question.
Well, so in my brain, I'm thinking about the person that wants to play with Terraform and they want to play with Terraform Stacks, and so there is a free tier that we have, and I believe I did do a cursory examination of some of the pricing options. There are some functionality and features that you can get from via CE that you can get an increased amount of functions and functionality through up to HCP free tier, but you don't get a lot of the big things like multiple or I think it was multi-conditional deployment groups until you hit all the way up to HCP premium tier. There is some structure to how they've priced it out. The one question that I had, and I can Google this too as we continue on, was how much can you get away with in the HCP free tier? But I'll look into that myself because I'm curious about that.
I don't believe HCP Stacks is available in the free tier.
It's not, okay.
I don't believe because
the last time I checked, no.
Also, I'm not 100% sure if it's in the premium tier because there's a tier in between, right? Because normally those questions, normally like I will defer those questions to account managers,
Okay.
But I'm happy to answer it later.
No. It's okay. We've got way cooler things to talk about than pricing. But I also want to know, for our audience, what they can, how much of this they can play with without spending any money. Because the first thing I want them to do is sign up for an AWS account. I get them on the year of free stuff first. But that's totally cool. Okay, I also had more questions about link stacks, but I will wait until after the demo because I think a lot of my questions are going to be answered by that. So I will shut up. Shala, was there anything else that you wanted to get into?
Yeah, just a couple that came to mind, and let me know these may be better answered at the end, or maybe it's going to get answered. But one of the questions I have, of course, me as always, how does one get started with using Terraform Stacks? So. And then the other thing was, what's a good rule of thumb to decide when to use Terraform Stacks and when not to?
You can start using Stacks at any time.
Okay, so hold on. This is absolutely amazing. Somebody that is watching the show right now, Miles Harrison, who is an employee, just slacked me on the internal Slack. Hold on. I'm gonna stop this for 1 second. I'm gonna add Terraform Stacks, and I'm gonna add Harrison's screenshot. Thank you, Miles, for this, because he gave me he sent me the pricing structure. Let me escape this and minimize this and bring this over here. So Essential, Standard, Premium, and Enterprise, these are the various things that we can get away with in Stacks. So we have the option for Stacks in Essential, Standard, or Premium, not in Enterprise, but we also have Stacks custom deployment groups in the Premium version, but not Enterprise, Standard, or Essentials. So amazing. Miles, thank you so much.
Thank you. And for anyone listening, Essentials, does that line up to free, or where does that flavor fall under?
Do you mean free tier, open source, or essential? Actually, I was thinking about that too.
Yeah, because people watching may not know, like, okay, essentials, like, do I pay for that or is it free?
Essentials is the old standard tier. Free tier went away. Miles for the win here. Thank you, sir.
You.
Shablam.
To answer Shala's question regarding I would recommend we have a blog published by the product team regarding stacks. Also, we have two tutorials, one for EKS, because that one is focused on how to manage dependencies. Because when you use EKS, you have dependence on add-ons, namespaces. So there's a tutorial for that. You can get hands-on using AWS. Another tutorial is stacks, just how to use stack and learn how to use it. On top of that, I will share in my slides. We have some public repo called HashiBank. We have like 7 components in stacks. Also, we deployed on development and product environments. So that's a more complex stack deployments. You can try from there to learn stack. Regarding for a company, when to start it, really depends on. That's why that's the question. I'm going to talk about through the deployment use cases.
Cool.
We can go over there. Also, I would say for some open source customer who's using Terraform, because they share the same concept. Do not repeat yourself. So if they want to take advantage of Terraform enterprise features like Sentinel policy, private module registry, many other different features, they should start thinking about migrate from Terraform into stacks.
Cool.
Let me share my screen. How do I share it?
So your screen is back up. If you want to flip over to code, I believe you have your full screen share up.
I'm not ready to share the code yet.
Okay.
It's my screen. Okay, cool.
Yeah,
sharing.
It's there.
Great. So let's go over some deployment use cases. So actually, in my day-to-day discussion with customers, whether they are navigating a cloud transformation or undergoing a broader organizational change to adopt infrastructure as code and refine their operating models, I often find that they can split them into 2 types, as the platform resources and workflow resources, based on the scope and the concerns each one carries. So for the platform resources, a team whose responsibility is to manage the foundation elements that are broadly deployed across many accounts and regions. Think of shared networking, security baselines, and some common services that need consistencies at scale from a management standpoint. So the other spectrum, you have like workload resources. So now think about application teams. They need specific infrastructure deployed to their target environments and regions. Their concerns are slightly different. So rather than consistency, they want deployment order to be enforced and to make sure that detailed configuration for their business requirements are met. So in short, it's a sort of battle against the consistency and ordering. The number of accounts you're targeting in relation to stacks or resources you need to deploy becomes an important factor. Now let's try to look at the platform resources from a stacks standpoint. So think of like base networking or other foundational resources you need to manage. For example, a VPC, you could build each layers of infrastructure as separate components. So you might also include IAM roles, permission sets, or any other components required to support deployments across the accounts of your managements. And it could include some other resources as well, such as S3 buckets or anything of a similar nature. So now you can group these pieces together. So each one is an individual component, and they may map back to modules you have already created. So these components can be combined to form a deployment consider a higher level construct that represents something you ultimately want to deploy. So this idea of a deployment composed of multiple components isn't something that workspaces or individual Terraform modules provide today. So with this concept, you now have the ability to stagger deployments across different environments. So you can take a deployment, made up the specific components you need, and provision it according to the requirements of each environment. As I mentioned earlier, you can define which deployments are auto-approved, for example, in a development or sandbox environments. So you have more flexibility and tolerance for rapid change. So auto-approval may be perfectly acceptable. But in the higher environments, such as production, you may want to review every proposed change, and you will definitely want to examine anything that involves deletion. So from a consistency standpoint, it gives you a clear framework to apply approval rules across deployments, ensuring that the foundational infrastructure is managed appropriately across all environments.
I actually really love that no delete conditional that's baked into the deployment group. The number of times that you've had to approve or use the switch for auto approve is all the time. So the fact that that's baked in there is it's not a time saver because you're already you're accommodating for it in a different way otherwise, but it's really sweet that you're actually calling that out as a rule set now so that you're not having to use an external validation thing before you say, okay, are you deleting anything? No, proceed. So bravo. That's a really nice feature.
Cool. So let's look at from a application team standpoint. So we're gonna tackle EKS and some workloads that we will probably provision. So think of this from as a perspective of application team that's trying to provision a workload as part of their deployment. So we are still going to consider the VPC, whether it's created as part of the stack or whether it's already exists elsewhere. So to deploy a pod, for example, you need the EKS cluster to be present. And once you look at EKS, there's a certain add-ons you will want to enable along with a specific namespace where the application should live. And there may also be service accounts, secrets, and other application-specific resources that become part of your application stack. So we are not done yet. We still need to complete the pod deployments because that's where the business value actually is. And you can have the cluster, the VPC, and all the baseline infrastructure. But until the application itself is deployed, running, and available to users, the business value isn't realized. So, and similar to the platform infrastructure, you can group them together as a deployment. Now, the slight difference here is the order. So anyone who has worked with the Kubernetes, the Helm provider, or even the generic AWS provider knows there are nuances in how resources relate to one another, especially around when specific endpoints become available. So in this example, the EKS cluster must be available before you can provision the namespace or install add-ons. You might also need role-based access control rules or other application permissions. So some providers require the cluster's endpoint to be available before you can execute. That's where Stacks helps by handling this ordering for you, so you don't have to manually manage it. So let's work through it. Suppose the VPC and EKS cluster are part of your deployment. The VPC gets deployed first, then the EKS cluster. For you, it's still a single deployment. For Stacks, it's a base layer that's deployed first. When Stacks detects the cluster is available, it moves on to deployments like add-ons and namespaces. So when those are ready, you can then proceed to deploy the application pods. For the same scenario, if you use Terraform workspaces, the workspace will fail if you don't apply run triggers to manage dependencies. So Stacks automatically identifies these dependencies, understand which resources need to be created first, and uses Terraform's knowledge of resources relations to order everything correctly. So after that, the pattern is the same. You have deployment made up of components that can be provisioned across any environments you choose, and you still have the flexibility to simplify how you want these deployments to be approved, whether that's manual or automatic, depending on the life cycle stage and your organization's tolerance for changes. So we look at both the platform resources and the workload resources and how they fit into the Stacks model. The goal is to design a structure that reflects how your environments operate, define what you consider a deployment, and organize the components accordingly. So there are cases, you want to manually review changes depending on the context and the information available to you. To summarize this section, from a platform standpoint, we are talking about well-defined, repeatable infrastructure that can be deployed consistently at scale across environments. There are countless use cases that build on those foundational elements. Also, from a application standpoint, the idea is similar. The difference that we're focusing on how you can leverage ordered changes, understanding what needs to happen first, and how those dependencies flow so you can deploy reliably across environments without constant manual coordination. So early, we look at the EKS example where we had multiple components layered together. So deploying process works the same way. The difference that Stacks handled orchestration behind the scene. It figures out when to deploy each piece with the necessary dependencies and ensure that replanning happens at the right time. So Stacks examines the context to determine what can be created first. So even if you have 6 components in a deployment going into an account, Stacks automatically maintains the correct order based on what application requires. So hopefully seeing those relationships and how Stack manage them has been helpful. Any questions?
Charlotte, did you just clear your throat? No, you didn't. You're muted. No, I do not have any questions right now.
Okay. Yeah, I'm muted. I'm actually trying to. I have a sneeze.
Oh yeah.
That wants to happen.
From reInvent, yeah.
Also, the next I would like to talk about the future version of Stacks. First, we want to work on the deployment groups. So currently, you can only have like 20 deployment groups, but we understand, or to work with enterprise customers, they need to manage hundreds or even thousands of deployments per Stacks across different accounts or tenants. That's why, in the next phase, we want to change the limit to 1,000. Also, we are introducing rollout orchestration, defined entirely in configuration. This will enable sophisticated, automated, phased, and progressive rollouts with failure thresholds, scheduled rollout rates, and other controls you will expect in a large operations. I haven't tried this feature yet. I'm looking forward to try it and to see how it works. The next one is migrate existing Stacks workspace into Stacks. We want customer to fully embrace Stacks. We need to make adoption painless. So right now, migrating existing production Terraform workloads from standalone workspaces into Stacks is a manual, state-intensive process that creates a lot of friction. So our plan is to address this by introducing a CLI-driven migration workflow, which is already in progress and will be released very soon. The workflow will automate configuration generation and state transfer, giving you a seamless and efficient way to move your existing infrastructure into Stacks structure while preserving the state integrity and minimizing disruption. So this means in practice that you will be able to run a few commands and migrate multiple workspaces into a single stack. If you currently manage separate workspaces for devs, stage, and product, you'll be able to consolidate all of them into one Stacks and manage their entire life cycle from a single place. So I think that's a really cool feature because when I work on demo, I try to do some stacks migration by myself. Then from workspaces into stacks, then I found it was really painful. I need to rethink everything. How stack works compared to workspaces. It could be really time consuming for migration. I think this tool is going to be very critical to help our customers to be successful by using stacks. So now we will see a really quick demo about how Stack works. First, I would like to show you the source code. So we can start by looking like what's the configuration file look like. So this is the components file. So which is the heart of the system. So we have broken our EKS HashiCorp applications into 6 essential components. You can see we have VPC here. We have EKS, case add-ons, namespaces. And the final application is the HashiCorp, deploy HashiCorp. You also notice that components are utilizing other components. For example, in the component case namespace, use output value of component case add-ons. So this is Stack natively building the dependencies graph for you. So the EKS cluster depends on the VPC outputs, and other components depends on EKS outputs. Stack understand of all of these, which eliminates the need for you to write custom scripts for manual sequencing logic. At the bottom here, I have published an output, which will be utilized in another stack. It is link stacks use case. The next one I want to show you is the deployment configuration file. So this file defines environment, reputation, and governance rules. We have one type deployment, and another one is the product deployment. So both of them are individual assigned to one deployment group. So you can see there, we have 2 deployments group here. They have just also we have defined auto approval rule in the dev group. So deployment auto approve dev plans. Product group doesn't have the rules because we need to do some manual control here. Here is a save dev plan. This plan passes safety checks. So change is automatically applied, removing friction and accelerating developer iteration. The published output in the VPC, this one, is how you actually publish the output that exposed in your configuration file and will be available in your downstream stacks to use. 1 second, let me switch back to my. Okay.
Now, I actually found the repo for that. Other than an AWS account, if somebody else wants to play with deploying that stack themselves, they need an HCP account, an AWS account, and that repo. Is there anything else that they need?
I think that's all they need. Also, they need to use CLI if they want to, right?
Right. The CLI installed.
But they can also play on Azure and GCP.
Sure. Yeah. No, I did not. Sorry, I did not mean to belittle all of the other CSPs. Like I said before, Charlotte and I just got back from reInvent, so I have AWS on the brain, and it looks like the stuff in the demo was AWS stuff. So I didn't want to confuse anybody. Sorry for the Azure and GCP watchers in our audience.
Okay, so let's look at the UI of the stack. Let me play it. Okay. So we just commit the update to our case add-on components. So Stack immediately recognizes the changes, and the queues runs for both dev and production. Now we are looking inside dev environments. The plan was automatically approved, and now it's applying those changes. This is the instant velocity we talk about. Here is the technical details worth noting. You can see EKS is a component applying first, and is it running? I don't think the video is loading. I'm sorry.
Yeah, it looks like it may be buffering.
I can do this, although, but you can still see the EKS is applying first, while everything else is waiting. This is how the auto approval and orchestration logic shows up in the UI. So you can also see a timeline of each action occurred. For some reason, the video is not loading.
Maybe if you refresh the browser.
Let's see. It's not working, but anyway, I can still.
Okay, sure.
And the next one I want to show you is this is the exposed VPC ID is being used by another stack. So at any time the ID changes, Stack will automatically trigger updates in the dependent stacks as well. Let's see. Yeah, that's what I'm going to show you. So the next one I want to show is the Stack has detected missing API dependencies and the pause plan, to allow the EKS cluster to finish applying first. So this is exactly the kind of dependency handoffs that we were showing earlier, and Stacks handle it for you, eliminating the need for custom scraping. Now the EKS components has fully applied. So the remaining components, if you see here, the remaining components can proceed. After that, you can switch over to product and manually approve the plan here. Just a very quick demo for the Stacks. So that's everything I have today, about Stacks. I have a demo. I talk about the presentation. I talk about the use cases. Also, I had a quick demo. Now I'm open for any questions you have for Stacks.
Okay, and what I'm also going to do is in the show notes, I'm going to provide a tutorial for Stacks that I believe actually uses, is that the same? Okay, yeah, AWS account, HCP account, and the CLI. Oh, and it includes all three clouds because I was being horrifically AWS centric. So, oh, you put the links up. Yep. Good job, YuZhao. Awesome. Okay, so we covered the deployment file. We covered the component file. We covered link stacks. So in your opinion, what is the easiest way for somebody that has exposure to Terraform to also start learning how to do link stacks? Should they use the tutorials? Is the repo the best way to get into it?
Actually, the tutorial doesn't have the link stack, doesn't contain link stacks. I would recommend to start with the blog, read the blog. Also, if you read the blog, there's some links we have documentations about the link stacks. Also, try this one, HashiBank, this repo. So you can find some code, sample code for link stacks. Okay.
Cool. Well, I will have all of those in the show notes. And I think you covered the questions that I had.
Great.
We got into yeah. No, this was great. Shala, was there anything else that you wanted to cover?
No, they were covered. So yeah, I just had the ones that I asked earlier, and yeah, this helps. So thank you.
Cool.
I actually need to play around with stacks.
You should. It's so much fun. At least from my personal experience.
Yep. Awesome. Okay. So we are going to do the giveaway now, but I am going to, Shala, don't hate me for this, but I'm going to ping Miles Harrison because he saved our bacon not only did he save our bacon, he was the first person to watch the show, but then contact me outside of the stream, like literally use back channels. That was very, very clever of him. So Miles Harrison, you will have the right of first refusal. If you want to win the weekly prize, which is $55, excuse me, not 55, $50 in AWS compute credits, then let's have a conversation. Yeah, you know how to find me clearly. So tell me if you want that. If you do not, then we will pick a random member of the audience and award them with the $50 in AWS compute credits. So congratulations, Miles.
I want credits.
And no, you don't. You're a community builder. You get all the free credit. Look at you. What are you even thinking? Dead to me. Forget it. Just got back from reInvent. Was just given an unlimited number of compute credits, and you're like, I'll take some more. I admire you for this. All right, everybody. YuZhao, thank you so much for coming on. I know it's still earlier your time, but it is later our time today.
Thank you for having me. I know it's late in your time. I really appreciate that.
No. It's totally okay. We really enjoy doing this.
Yes.
And congratulations for you said that you wanted to start getting out into the broader speaking audience. So congratulations on your first go. So huzzah all around. All right, everybody. I am not sure if we have a show next week. If we do not, then this was the last show of the year. Next week, Mark Tinderholt asked if he is another HashiCorp ambassador. He asked if we would hold the slot closest to Christmas for him for a special episode. I don't know what that means, but he said that he wanted to hold it. But I have not talked to him since HashiConf, so I don't know if he has anything. So we'll find out. But if it wasn't, then YuZhao, you gave us the last talk of the year. Congratulations.
But the reason I did it, I do this show because I want to do before him.
Well, in that case, he has to.
Vacation, 3 days, 3 days earlier.
Oh no, then he has to. Oh, he better. Oh, if he doesn't have something now, you will have strong words with him. All right. Next week, Mark Tinderholt will have a talk, or YuZhao will come after him, and we don't want to see that. All right, everybody, have a wonderful evening. YuZhao, once again, thank you so much for coming on the show.
Thank you.
Inshallah, I will be talking to you once again, as always. And hold on. Mr. Miles Harrison responded. He's going to pass on the credits. Okay, so we will do our random giveaway and give it to somebody from the audience. Congratulations, random winner. I will ping somebody once I do the turnstile and get those credits out to you. And we will see you all again next week. Or YuZhao will, or Mark Tinderholt will stop existing because YuZhao will come after him for ruining her vacation. All right, team. Have a good night. Bye-bye.
Okay, bye.